So welcome students. Today what we are going to study is electric dipole. Already we have studied about the point charges. Under the point charges we have studied the Coulomb's law, that is the force between two point charges, and then we have studied about the electrical field at a point or electrical field at a point due to a point charge. Like that we have studied about the point charges. Today let us go on with the next topic, and the next topic is called to be electrical dipole. What do you mean by this dipole? See, we can separate this into two. One of the part I can say that di representing two, pole it is considered to be end or ends. So two ends, that is a dipole. How we can able to define this? See, regarding the definition, it was being stated as two charges which are equal in magnitude, two charges which are equal in magnitude, but opposite in nature. But if it is opposite in nature, separated by a small distance, said to constitute an electric dipole. See, again, two charges, maybe QQ, which are equal in magnitude, opposite in nature. If one of the charges minus Q, then the other charge is considered to be plus Q. So opposite in nature, separated by a small distance, then that arrangement said to constitute an electric dipole. Let us see it diagrammatically. Let us consider two charges. Let the magnitude of one of the charges Q. So the magnitude of the other charge is also Q. If you are considering one of the charges minus, then other charge we have to consider as plus. So two charges which are equal in magnitude as Q, opposite in nature, one is minus Q, another one is plus Q, separated by what? Separated by a small distance. If you are considering that small distance as 2a, then we are calling this arrangement as what? We are calling this arrangement as electric dipole or electrical dipole. So two charges equal in magnitude, opposite in nature, separated by a small distance, said to constitute an electric dipole. See, we can state some examples. Most of the molecules are considered to be electric dipoles. See, we can take like this, many molecules like water molecule, that is H2O. Then we can say ammonia, NH4. Then we can say methane, CH4. Then carbon monoxide, CO. And we can say hydrochloric acid, HCl. All these molecules are said to be examples for what? Examples for electrical dipole. Examples for permanent electrical dipole. These are considered to be examples of permanent electrical dipoles, and these permanent electrical dipoles are having permanent dipole moment, What is that dipole moment? Let us see later. First of all, you just consider the examples, and along with the examples you consider this point, I will explain. What do you mean by this dipole moment? So, many of the molecules like H2O, water, ammonia, NH4, methane, CH4, carbon monoxide, CO, and HCl, so many, etc. are considered to be some of the examples for permanent electrical dipole. Since these are permanent electrical dipoles, they are said to have permanent dipole moment. So we have to see what do you mean by this permanent dipole moment. What do you mean by this dipole moment first of all? See, if you want to study about the strength of the dipole, then the strength of the dipole can be studied with the help of the dipole moment. Okay, if you want to study the strength, so the strength of an dipole, of an electrical dipole or of a dipole can be studied by the dipole moment. If it is considered to be a permanent electrical dipole, then the dipole moment is also called to be permanent electrical dipole moment. Now, the question arises, how you can define this electrical dipole moment? So, let us go for the next one. The next one is define electric or generally called to be dipole moment. How you can able to define dipole moment and get the expression as well as the unit. Let us consider. Define electrical dipole moment. See, first of all, we can say that the dipole moment is used to measure the strength of the dipole. How you can able to measure? Usually, electrical dipole moment is defined as the product of one of the charges and the perpendicular distance between the two charges. Perpendicular distance between the two charges considered, or between the two charges. This we are calling it out as the definition for electrical dipole moment. You see, you are having what? Electrical dipole moment is defined as the product of one of the charges. Out of the two charges, you consider one of the charge and the perpendicular distance between the two charges. See, this dipole moment is represented by, okay, let us write like this. Dipole moment is represented by P. Since it is an vector quantity, we are writing it as P vector. So I can state P vector. Magnitude of P vector is equal to, that is modulus. Magnitude of P vector is P, which is equal to, see what it is given. Electrical dipole moment is defined as the product of one of the charges. Product means you multiply one of the charges Q and the perpendicular distance. So written as 2A, which is again equal to, I can write it out as 2QA. What is its SI unit? See, we can state the SI unit as Q measured in terms of coulomb, CA distance measured in terms of meter, so coulomb meter is its unit. Okay, this is in general. What about the direction and how we can able to get this expression? We can derive. So how you can able to get this expression? So derivation for that expression. So let us see how we can able to get that expression. See, in order to get that expression, that is P is equal to Q into 2A, let us again consider the diagram. What I have taken two charges. One of the charge I have taken it as minus Q, and another charge I am considering it as plus Q. So these are the two charges considered. Let us take the distance between the two charges, one at this position and another one at this position. Let us take that distance between the two charges as 2A. Let us consider the center point as the origin. Let O be the origin. If O be the origin, then from the minus charge to this O, I am considering it as A. Or we can represent it as R minus. Generally, R is used for measuring the distance, so R minus, that is from the negative charge. Similarly, from the positive charge to the point O, again the distance is A. If it is represented in terms of R, I am representing it as R plus. Now, what is the electrical dipole moment? See, we are going to calculate the electrical dipole moment. Moment means force into distance about the origin. So, about the origin. About the origin means origin O. About the origin O. What is that? About the origin O, I can write P vector is equal to one of the charge. I am considering this charge, that is minus Q, multiplied it with the distance. Distance means from the origin to the charge. I have represented as R minus. So R minus plus. We are having another moment with the help of the charge plus Q. So again I am writing plus Q multiplied it with the distance, that is plus Q from origin at a distance of R plus. Clear? So now substituting P vector is equal to, you see, minus Q multiplied it with, see, R minus. R minus is in the negative x-axis of the origin. Since in the negative x-axis, I am writing it as minus A. Plus, I can get again plus Q. Then the distance is along the positive x-axis from the origin. So I am taking it as plus A. So on simplification, minus into minus, I will be able to get plus. So Q into A plus again Q into A. So I can get the answer as 2QA. Along what direction? Along the x-axis, along the I cap. So I can state that P vector is equal to 2QA. See, the dipole moment is given by P vector, which is equal to 2QA. This gives you the magnitude. What about the direction? It is acting along the x-axis. So I am writing it as I cap. So if it is I cap, both are positive. Both are positive means it is acting from along the positive x-axis, that is plus I cap. So I can say the dipole moment is having the direction acting from minus Q to plus Q. So I can write again, therefore dipole moment or electric dipole moment is given by the formula. What is the formula? P vector is equal to 2QA, this is magnitude, multiplied it with I cap. So I can state this definition again using this. Or how I can state this definition? So modulus of P vector is equal to the dipole magnitude of the dipole moment P, which is equal to Q into 2A. That is the product of, that is the product of one of the charge, product of one of the charge and the perpendicular or the shortest distance between the charges. Perpendicular or the shortest distance between the charges. This is what we are calling it out as the dipole moment. Now you calculate, you consider the direction. See, what is the direction? Always dipole moment is acting from, I can write like this, dipole moment always acts from minus q to plus q, that is from negative charge to positive charge it is acting. Then what about its SI unit? Let us write again. So SI unit is equal to coulomb meter, not centimeter. It is written as coulomb meter. Coulomb a space, and then you have to write out what? You have to write the meter. Okay, if you are having two charges. See, let us consider a special case. What is that special case? If more than one charge is considered, if you are having more than one charge about the origin, so more than one charge, then the electrical dipole moment, or you can say like this, or for the collection of charges, or for the collection of charges, then the dipole moment is given by, what is that dipole moment is given by? P vector is equal to summation. So sigma of Qi or I vector. Here, what is I? I is equal to 1 to n. What is Ri? Where I can write Ri vector is the position vector. There is the distance. I can say it as the position vector of the charge Qi. From where? From the origin. Okay, Ri is the position vector of charge Qi with respect to origin, or we can write from the origin. Clear? It's very important. 3-mark question. If it is asked in 2-mark question, just definition alone will be asked. If it is asked in at a 3-mark question, explanation will also be asked. Okay? Clear? See, again, let us recall what you have studied. See, today, we have started with a topic called to be electrical dipole. What do you mean by this electrical dipole? What do you mean by this electrical dipole means? We can state that electrical dipole is an arrangement where you are having two charges which are equal in magnitude but opposite in nature, separated by a small distance, constitute an electrical dipole. You are having diagrammatically it is represented like this. There are having so many number of examples, and the examples are taken to be, see, many molecules like water, then ammonia, methane, carbon monoxide, hydrochloric acid, are some of the examples of permanent electrical dipoles, and these permanent electrical dipoles are having permanent dipole moments. Then how the strength of the electrical dipole can be measured with the help of dipole moment. What is that dipole moment? Using this dipole moment, the strength of the electrical dipole can be measured. So what is that dipole moment? Electrical dipole is defined as what? Electrical dipole is defined as the product of one of the charges and the perpendicular distance between the two charges. So the dipole moment is represented by the letter P and it is a vector quantity. So I have written it as P vector. So P vector is equal to P equal or modulus of P vector is equal to P, which is equal to one of the charge Q multiplied with 2A. So product of charge and distance. And when you are multiplying it, you can write it out as 2QA. And the SI unit is in coulomb meter. We can obtain this expression by considering an electrical dipole diagram. See what I have taken in order to calculate that expression. I have taken minus Q and plus Q separated by a distance of 2A. Let O be the center point or the origin. From the origin, minus Q is at a distance of R minus, or I can say from the origin it is along the negative x-axis, so I can write it out as minus A. And from the origin to plus Q, the distance is R plus, or I can write it out as plus A. So electrical dipole moment about the axis of or axis or about the origin moment itself, it is considered to be force into distance, or here charge into distance. So P is equal to force is due to the electrical field, you can able to get the force. So minus Q into R minus plus Q into R plus. R minus is minus A. So minus Q into minus A plus Q into plus A. So QA plus QA, I can able to get 2QA. So P is equal to 2QA. Since you are considering vector quantity acting along the positive x-axis, it is written as I cap. So dipole moment is given by the formula P vector is equal to Q into 2A I cap. Now modulus is given by modulus of P vector is equal to P, which is Q into 2A. That is again the same definition what I have written in the previous case. That is product of one of the charge and the perpendicular distance between the charges. So what is the direction? This is magnitude. Q into 2A is magnitude. What is the direction? It is I cap. That is positive x-axis. That is from minus Q to plus Q. So the dipole moment always acts from the charge minus Q to plus Q. And the SI unit for this is coulomb meter. And another one, let us consider a special case. What is that special case that we are considering means? If you are having more than one charge, or if you are having collection of charges, then what you can do, or how you can able to determine the dipole moment? Then the dipole moment is given by the formula P vector is equal to sigma of Qi or I vector, where I varies from 1 to n. And what is that Ri? Ri is nothing but the position vector of the charge Qi from where? From the origin. This we are calling it out as the dipole moment. Clear? Thank you. Let us see in the next video.